So let x of t be e to the power of minus 3t ut. We want to find out whether if it is an energy signal or a power signal or neither. So first let us try to sketch the graph for this. So it is going to be something like this, minus t u of t. So if I want to find out whether if it is an energy signal, what I have to do is I have to take the limit t tending to infinity minus t to plus t x of t the whole square, magnitude of x of t the whole square. So if I try to substitute for x of t, so it becomes negative of t to positive t. Sorry, let me put the limits. So the signal actually starts from 0, t is equal to 0 and goes right up to t is equal to, so let us say t, e to the power of minus 3t dt. So if I do the integration, it is something like this, t 0, so it will be 3 e to the power of minus 3t minus 1, so it will be finally 1 by 3 minus t, and of course we have the limit t tending to infinity. If I substitute for infinity here, it will be, this one will become 0, so finally it will become that. So it's a finite quantity, so energy is a finite quantity, so it is an energy signal. So if it is an energy signal, then it is then the power will be equal to 0 in this case. So we can conclude that this one is an energy signal. So next one is, let us take the next example. X of t is equal to e to the power of plus j 2t plus pi by 4. Okay. So if I want to find out whether if it is an energy signal, I have to do this limit t tending to infinity minus t to plus t, magnitude of square dt. Now you know that it is 1, so this one will become 1, so it becomes minus t to plus t dt t tending to infinity. So finally I have this is equal to limit t tending to infinity to t, and this becomes infinity. So the energy is infinity, so it's definitely not an energy signal. So let us try to find out whether if it is a power signal. So power signal is nothing but limit t tending to infinity 1 by 2t. Same thing, so I'll write the whatever here comes here. So put this, so it becomes limit t tending to infinity 2t by 2t, and this becomes 1. So power is equal to 1 and energy is equal to infinity, so it is a power signal. So I can conclude that this signal is a power signal. Okay, so let's take another example. Let us say x of t is equal to cos t. So e is equal to limit t tending to infinity minus infinity to plus infinity cos squared within modulus squared. Now this I can write it as 1 minus cos plus cos 2t 1 by 2 t t limit t tending to infinity. So if I integrate this, it becomes t plus sine 2t divided by t, and you have the limits t and LM is limit is t tending to infinity. Now this becomes infinity because we don't this quantity, that is sine 2t divided by t, will become 0. Okay, but this the other quantity, the other term, that is t by 2, will become t, and when limit t tends to infinity, the answer becomes infinity, so it is not an energy signal. So whether if it is a power signal, let us try to, it is a power signal, let us try to find through that. So power signal, it is limit t tending to infinity 1 by 2t minus infinity to plus infinity 1 plus cos 2t and half comes here dt. So again in this one becomes 2t, sorry, this one becomes t, and this one will become sine 2t by 2, and you have all these terms here, 2t 1 by t 1 by 2 limit t tending to infinity. So if I try to substitute, this will anyway become 0. So this will be 2t divided by 2t into 1 by 2. So this will become half. So it is a power signal. So the signal is clearly a power signal. Okay. So next one, let us take a discrete time case. Discrete time example. So far we have been dealing with the continuous time. So let us try with the discrete timing case. So we have x of n is equal to 1 by 3 of n un. Now we want to check first whether if it is an energy signal. So it is limit n tending to infinity, small n is equal to negative n to positive n, x of n, take the magnitude and square it up. Okay. So this signal starts from n is equal to 0 because you are having a un. So the signal will be something like this. So it's going to be something like this. Your x of n is going to be like this. So it's going to start from 0 to capital N, and this one is going to be n, limit n tends to infinity. Now this will become 1 minus 1 by 3. You are having n plus 1 terms here, so it is going to be n plus 1 divided by 1 minus. Now as n tends to infinity, suppose if in this case if n tends to infinity, this will become 0 because it is less than 1. If it had been greater than 1, it would have become infinity, it had gone to infinity, but this 1 by 3 is actually which is less than 1. So anything multiplied by the 1 by 3 multiplied by n, and if the n keeps on increasing, suppose from 0 to n, 0 to infinite values, then this term will become 0. So finally you end up having 3 by 2, which is a finite quantity, so it is an energy signal. So if it is an energy signal finite, and this finite quantity will be divided by 1 by 2n, and if that n is if it is if the limits are applied to that 2 power n, which will be in the denominator, then this entire quantity will become 0. So it is, so the conclusion is this one is an energy signal. Okay, I think the first problem, I think there was some mistake which we discussed. Let me go back to that problem. This one should have been 6. Sorry, I think 6t. So all these things will change now. But anyway, the result is not going to change. Okay, so it is going to be minus 60 by negative 6, negative 1 by 6 into e to the power of 6t. So finally the answer is going to be 1 by 6. So still it is the result doesn't change. So we have completed this problem. We'll take up another next problem. Let us take a case where x of n is equal to e to the power of j times pi by 2 times n plus pi by 8. Now we want to first check whether it is an energy signal. So limit n tends to infinity, n is equal to minus 2 plus n, and within the I have to take the magnitude of this, and then I have to square it. So this quantity will become 1. Okay. So e to the power of j theta, if I take the magnitude of this, it will be 1. So it will be minus n to plus n, limit n tending to infinity 1. So this will be 2n plus 1. And if I apply the limit, I have to apply the limit. If I apply the limit, this one will become infinity. So it is not an energy signal. Is it a power signal? So the entire thing is going to, the result of the energy signal is going to be there. And this will have to be divided by n plus 1. And I have to apply the limit to this. If I do it, I'll get 1. So it is a power signal. This signal is a power signal. Again, I think I made the same mistake in the previous case also. Here it should have been twice, so this becomes 9. Okay, so let me remove this. It should have been square. If I try to square this one, this becomes 9. So here we'll have 9 here. But however, the result is going to change. So you got a 1 by 9 here and 1 by 9. So finally you're going to be 9 by 8. So still the result has not altered. Okay. So let us take another case. So let x of n be equal to cos pi by 4 times n. Now first let us check whether if it is an energy signal, that is limit n tending to infinity, n is equal to minus n to plus n cos pi n the whole square. So this I can write it as limit n tending to infinity, n is equal to minus n to plus n, and this I can write it as 1 plus cos pi by 2n. Now this we can write it as n is equal to 1 by n 1 plus limit n tend to infinity cos of minus n plus n pi by 2n. Now this term becomes 0 because if it will alternate between 1 and minus 1, so you will be continuously you will be getting like this. So it will be minus 1 goes on like this. So if you get this, finally you will end up, if you this will get this will become this will become 0 this term. However, this term will be 2n plus 1. So it is definitely not an energy. If I try to apply the limit to this, it becomes infinity. But power signal is the result of the energy divided by 2n plus 1. And if I try to apply the limit to this, it becomes 1. So it is a power signal. Sorry, I think we missed out half here. So it is half. So all throughout there should have been a half. Okay, I think so. This one turns out to be, so this is the result. Next, let me take the next page. Let's try to solve a few more problems. Say let us say x of t is equal to t times u of t. So first let us check whether it is an energy signal. Limit t tends to infinity. Okay. Minus t to plus t squared dt. So this one will become, lower limit will become 0. So limit t tending to infinity 0 to t squared, and this will be t by 3 t 0, that will be t cubed divided by 3, and if I apply the limit this becomes infinity. So this signal is essentially a not a energy signal. So let us try to find out whether it is a power signal. A by infinity 1 by 2t 0 to t squared dt. So this will become t by 3 1 by 2t. You have the limit. So we have limit t tending to infinity 1 by 2t, and to this I have to apply, if I apply the limit, it will be t square t cubed divided by 3 times 2 into t, and if I apply this will be infinity. So it is neither a power signal, see, power is infinity, and also the energy is also infinity, which means this signal is neither energy nor power. Okay, let us take another case. X of n is equal to 2 times e to the power of j3. Clearly, this one is not very difficult. So e is equal to limit n tending to infinity minus n to plus n. Then this is 2 into e to the power of j2 by 3 pi n squared. So this will become minus n to plus n 4. Limit n tending to infinity, I can write as 4 times 2n plus 1. And if I substitute, apply the limit, this will become infinity. So, but if is it a power signal, I take the result of the energy signal, then I divide it by, and then I apply the limit. When I do it, this becomes 4. So this is a power signal. So let's take Let's take another sample. Let us try uh, this example. 1 plus x of t is equal to 1 plus e to the power of minus 5 times t u of t. So which means what I have to do is to find whether if it is an energy signal, I have to take the limit t tending to infinity integral minus t to plus t, okay, 1 plus e to the power of minus 5t whole squared dt. So this I can write it as limit t tending to infinity 0 to t 1 plus 2 times e to the power of 5t plus e to the power of minus 10t, the entire thing dt. So this will be t plus 2 by minus 5 into e to the power of minus plus e to the power of minus 10 divided by minus 10. Entire thing I will have to substitute this. If I do it, I'll get something like this. Minus 2 by 5 e to the power of 5t minus 1 by 10 e to the power of minus 10t minus 0 plus 2 by 5 plus 10, 1 by 10. So I end up getting this. But however, when I substitute this, when I apply the limit, this t will become infinity. So it doesn't matter what whether the what happens to the other terms. So ultimately the result is going to be infinity. So this is not an energy signal, that is the conclusion now. But let us check whether if it is a power signal. So for checking the power signal, to check whether if it is a power signal, I have to do the same. I have to take the limit t tending to infinity 1 by 2t minus t2 plus t 1 plus e to the power of minus 5t squared. So actually there is a modulus here. If there had been some negative terms, then probably that negative term would have been become positive. So in our case, we are not having that term. So I have not put the magnitude. I have not included the magnitude. But that's fine. So this becomes limit t tending to infinity 1 by 2t. So okay. Anyway, we are having u of t. The signal is actually u of t. So it starts from 0 to t. 1 plus 2 times e to the power of minus 5t plus e to the power of minus 10t dt. If I take the integration, it is t minus 2 by 5 e to the power of minus 5t minus 1 by 10 e to the power of minus 10 within brackets 0 to t. I have 1 by 2t and I have to apply the limit also. So it will be 1 by 2t into t minus 2 by 5 e to the power of 5t by 1 by 10 e to the power of minus 10t minus 0 plus 1 by. Okay, now let us try to apply the limits. These two will become 0. If I try to apply the limits, so t tending to infinity, these two terms will definitely will become 0, because 1 by, this is actually 1 by infinity, so this also is 1 by infinity, so these two terms will actually vanish. So finally we will end up having 1 by plus 2 by 5 plus 1 by 10, and I have 1 by 2t here, to which I have to apply the limit t tending to infinity. So this will be limit t tending to infinity 1 by half plus 1 by 1 by 5 times t plus 1 by 20 times t. So if I try to apply the limits, these two terms will again become 0. And so finally I'll be having a quantity which is half. So it is a power signal. So this signal is a power signal. Okay. Let us try to see if we can work out a few more problems. Okay, we are having a signal x of t. Let us say we are having a problem which is x of t is equal to u of t into u of 2 minus t. Now we know that u of t is nothing but this, and u of 2 minus t is nothing but, we have seen that in our past videos. So it will be like this. First this has to be time reversed and advanced by 2 units of time. So when that is done, finally when you multiply these two, you end up getting a signal something like this. Now we want to find out whether if it is an energy signal. So limit t tending to infinity. So the lower limit is 0 because signal starts only from 0, and then we have 1 the whole square dt, and you end up having t. So when you apply the limit to this becomes infinity. So it is an energy. It is not an energy signal. Okay. At least let us check whether if it is a power signal. So for power signal, I have to take let me take the result of energy signal, to which I have to divide by 2, and then I have to apply the limit. So when I do it, it becomes half. So it is a power signal. Power is finite, energy is infinite. So the signal that we just now seeing is a power signal. So let us take another example. Rectangular pulse t plus 1 divided by 2. So this we can visualize as t by 2 plus 1 by 2. So first we can take this, and then what we can do is we can shift this by the backward direction by half unit, and then what we can do is we can do the time scaling by 0.5. So this is 1 by half. 1 by half is nothing but 0.5. So let us try this. First let us take the signal. The signal is nothing but this one minus half, and you have a plus half here, and then you have 1. So from here we try to derive this one. So I have to shift backwards. So when I shift it backward, this becomes minus 1 and 1. And to get this one, what I have to do is I have to time scale. When I do the time scaling, the signal becomes, I have to multiply it by 2. Multiply the time axis by 2. So when I multiply the time axis by 2, I end up getting minus 2 and 0. So is it an energy signal? So limit t tending to infinity. So negative t to positive t, 1 squared dt. So it is minus of minus 2. So it is 2. So energy is finite. So it is an energy signal. So actually this gets evaluated to t, and you have, and this becomes like this. What about let us take another example. So we have something like this. R of t minus 2 R of t minus 1 plus r of t minus 2. So I will try, let me illustrate to sketch this signal. So you have r of t, which is like this, right up to 1, and because of this, this is having r of t minus 1 is having a slope of negative 2. If it is just negative 1, it would have been like this. It would have been a flat line. But since the slope is 2, it is going to become like this. And it is going to reach 2. And after 2, there is r of t minus 2. So instead of proceeding like this, it will flatten out. So finally, we are going to have a triangular shaped wave. This is x of t. Now we have to find the find whether if it is an energy signal or not. So for finding out whether if it is an energy signal, I have to take limit 0 to 1, it is t squared dt, because this one is t and this one is 1 minus t by 2. Sorry. Okay, let us try to understand what it is going to be like. So we are having a signal which is this one is r of t and this one is negative t. This one is t, this one is negative t, and I'll have to shift it by 2 units to the right. If I shift it by 2 units in the positive direction, then I end up getting this signal, this line. So when I do it, when I move it in the forward direction, I have to actually, what I have to do is I have to substitute in t minus 2, so it becomes 2 minus t. So what the signal is 2 minus t. So this for this part is 2 minus t. When I substitute 1 here, I get 1. When I substitute 2 here, I get 2. So this plus 1 to 2, 2 minus t the whole square dt. So I have to do the evaluate. If I evaluate it, it's going to be a finite quantity. There's no doubt on this. You can very easily find that it's going to be a finite quantity. So it is going to be an energy signal. So if a signal is an energy signal, then power is equal to 0. So power it is going to be 0. So this we can conclude that this signal is an energy signal. So this essentially concludes our discussion on the energy, whether the signal is an energy signal or not. So we have gone through a set of problems. In our future lectures, maybe when we do some crash courses, we will again touch upon this, and we will take more problems from some other textbooks or some other material that will be available. So for now, we stop here for energy and power signals. And what we do next is we will discuss the causal and non-causal signals in the next video. Thank you.